Hello everyone. So till now we have seen the image formation in concave and convex mirror, and we have also seen the sign convention rule. Okay, now what we are going to see here is the mirror formula. What is mirror formula? Mirror formula is basically the relation between three things, three distances. What are those distances? The distance of you can say the focal length, okay, image distance and object distance. Three things are there: focal length of mirror, uh, object distance, and the last one is image distance. Okay, so the relation between all these three things is called as the mirror formula. Now in this, among these three things, the focal length of mirror will be constant. The object distance and image distance are variable. It means they can change. Okay, if you will put the object here, image will form here. If you will put the object here, the image will form here. So u and v, the object distance and image distance can change, but as far as concerned with the focal length, so as the mirror is constructed, its focal length cannot be altered later on. Okay, so whatever the focal length we will have, we for that we will have a relation. So focal length is constant while the image distance and object distance can change. So for among these three things we have a relation. Okay, so in class 10th you may have studied about it, that relation is 1 upon f is equals to 1 upon u plus 1 upon v. This is the relation, mirror formula we call it. But here we are going to derive that relation, and particularly this case is the we are going to derive here. But for concave mirror, in the concave mirror there are two conditions, one for the real image and one for the virtual image. So right now we are going to derive the mirror formula for the real image. Later on we will derive the same formula for the virtual image also. Right now we will derive that relation for the real image. Okay, so for deriving that relation we need a little bit geometry which we have studied, okay, in class 10. So by that we can go we can solve this. So starting the derivation, okay, we need a concept of triangular similarities, and by all means that I think all of you have know about the triangle similarities. Okay, so I am not going to explain that in detail. For starting that derivation, there is this condition, that is a concave mirror, and for that concave mirror, this object AB is placed behind C, and its image is forming between C and F. We have taken two light rays. One light ray is going directly parallel to the principal axis, and after reflection it is reflecting back, passing through the focus. Second, we have taken the light ray is going through the center of curvature, and it is reflecting back along the same path it is reflecting. So here we will use triangular similarity, but before that we will draw a perpendicular from this point L, from point of incidence to this principal axis. You can call it LN. Okay, this will be perpendicular, and this LN, this P and N, this P and N are very much close to each other. Okay, and another thing you can write here, that because this line is parallel, so AB is equals to LN we can write. Okay, what we can write? AB is equals to LN. Okay, AB is equals to LN. By geometry we can say. Okay, by geometry what we can say, that AB is equals to LN, because these AB is also the line between, perpendicular line between the parallel rays, and that is also your same thing is there. So AB is equals to LN by geometry. So now if we see here, we have two triangles. Okay, triangle we can write A dash, B dash and F is similar to triangle L, N and F. How it is similar? See, this AB is perpendicular over here, this angle, and this is also perpendicular, so both the angle are same, and this angle are opposite to each other, and if two angles are equal, then third angle will also be equal. So by AA similarity, or by AAA similarity, you can say that triangle A dash, B dash and F is similar to triangle, you can say L, N and F. By which similarity? By AA similarity, you can say. Okay, both of them are similar. So if both of them are similar, we can write this A dash, or we can write this Ln upon A dash B dash is equals to Fn upon Fb dash. Can we write this? Yes, we can write. Okay, because both of this triangle are similar. So Ln upon AB, A dash B dash we can write, and Fn upon Fb dash we can write. Okay, what we have written? Ln upon A dash B dash. So and here Fn upon Fb dash. This we have written by the triangular similarity. But here what we know the certain things. Okay, what we know here by this diagram, that this distance PF, this is what is this distance PF? Okay, I am erasing this. PF, what is this PF? PF is your focal length, and PB dash, this distance PB dash is your, you can say this distance is your image distance, so you can write V. Then C to P, this to this is your center of curvature to pole, this will become R. So this R you can write 2F, R is equals to 2F, we have the relation R is equals to 2F, and this A to P we can write this is your image distance. Okay, so what are the things which we have seen here? This object is placed here, so this distance here to here, this is U, this is center of curvature to pole, we will call it 2F, and this F to P is focal length, and V dash here, this is the image distance from the pole, so this will be your V. Okay, these three things. Now coming back to this, we have said that this Ln upon A dash B dash and Fn upon, you can say, Fb. Okay, so now here if you will see this Ln, we can write this Ln is equals to we can write AB, because Ln is equals to we can write AB. So this can be written as AB upon A dash B dash. Okay, and second is Fn. So Fn, N and P are very much closer. So instead of N, what we can write? P. Okay, these 2 points are very much close to each other. So instead of Fn, I will write here Fp. Okay, Fn is equals to, you can write Fp, and Fb. Now this distance are unknown. We don't have any name for this. So can we write in some form which can come in these two? Fb dash, this distance. Can we write this distance minus this distance? Fb can be written as PB dash minus PF. Okay, we can write like that. FB can be written as what? FB, this distance. This distance, what? PB dash minus PF. Okay, PB dash minus PF, we can say. So, F here, FB dash we have written PB dash minus PF, because PB dash is your V and PF is your focal length. So this can come in that form. So we will write this as your first equation. AB upon A dash B dash is equals to FP upon PB dash minus PF. This is our first equation. Now leave it there. We will use now another triangle we will see. So which triangle we will see? Let's say this triangle. ABC and A dash B dash C. These two triangles. This triangle and this triangle are also similar, because again this angle is of 90 degree, this angle is of 90 degree, this angle and this angle are equal. So this triangle ABC is also similar to triangle A dash B dash C. Okay, ABC is also similar to A dash B dash C. Okay, so by this what we can write? AB by A dash B dash we can write. AB by A dash B dash can be equals to CB upon CB dash. Okay, CB upon CB dash. C AB upon AB dash, you can write AB upon AB dash and CB upon CB dash. Now again CB is not in a number form which we know, like UB and F. These are not its form. So what we do, we will try to write in those form. उन form में लिखना है जो UB के form में आ जाए. तो अगर अपन CB की बात करें, this CB को अपन कैसे लिख सकते हैं? This CB can be written as BP minus PC. BP, इस BP पूरे से PC को सब्ट्रैक्ट कर दें तो अपने पास ये बच जाएगा, और BP U है और PC क्या है तुम्हारा 2F है. So BP minus PC. Okay, so CB is written as BP minus PC. So this can also be written as BP minus PC. Similarly, how we will write this? CB dash. CB dash we can write PC minus PB dash. This from P to C, one distance is there, that is your 2F minus PB. Okay, here this distance PC minus PC minus PB, PC minus PB, that will become CB dash. So CB dash is written as CP minus PB dash. Okay, so second equation, AB upon AB dash B dash is equals to BP minus PC upon CP minus PB dash. Okay, this is there. This is second equation. अब देखो दोनों इक्वेशन किसके बराबर है? A dash B dash की. A dash B dash मतलब A by AB upon A dash B dash, AB upon A dash B dash. तो ये दोनों टर्म इसमें क्या है? कॉमन है. तो जब ये इसके बराबर है और ये इसी के बराबर है तो दोनों एक दूसरे को अपन क्या लिख सकते हैं? इक्वल कर सकते हैं. सो बाय equation 1 and 2, what we can write? Fp upon P B dash minus P F is equals to BP minus PC upon CP minus PB dash. Okay, CP minus PB dash. Now these are just form of geometry. Now we will substitute their value. ठीक है, ये अभी तक जो आया है किसके फॉर्म में आया है? ज्योमेट्रिक डिस्टेंस के फॉर्म में है. अब अपन उसमें वैल्यूज डालेंगे. तो जो FP है, FP क्या है देखिए, FP दिस डिस्टेंस. अब ये जो डिस्टेंस जब मेजर होगी पोल से मेजर होगी, मतलब P से F तक की डिस्टेंस, तो अपन लेफ्ट हैंड साइड मेजर कर रहे हैं. तो जो PF होगा वो पॉजिटिव नहीं होगा, बिकॉज इट इज टुवर्ड्स द लेफ्ट. सो वी विल पुट हियर द नेगेटिव साइन. ओके, PF, this PF will be your negative. Okay, so PF is how much distance? F. So in place of PF we will put negative F. Okay, in place of PF we will put negative F. Negative F we are going to put. And what is PB? PB, P to B. This distance here the image is forming, so P to B is your image distance V, and this is also from the pole to the left. Okay, from pole to left it is, so PB is equals to, we can write minus V, that will be your minus V. Then what is P? Here minus sign is there. Then what is PF? PF again, that is your focal length, so negative, focal length is negative. So PF this. Now this side. Now here keep in mind, sign convention rule we have seen. When we are writing form like suppose here PF, so PF is the distance, but when we are putting its value is what? F. जब अपन उसकी वैल्यू पुट कर रहे हैं तो उस वैल्यू में साइन होना चाहिए. देयर शुड बी द साइन अलोंग विद द वैल्यू, बिकॉज PF is only giving the distance, but when you will put its value, so that along with the sign it will give you that distance is measured from pole that is towards its left hand side or towards its right hand side. So when you are putting the value, then you will put the sign. Like here we have taken FP, so FP is what? It is the just sign, it is just the distance, but when you are putting its value, then value you will put along with its sign. Okay, जो value put करोगे तो उसमें कैसे के साथ आएगा? वो sign के साथ आएगा. तो similarly if we will write here BP, so BP already BP, this is B and this is P. PP, this distance, pole to this is your object is placed here, then this pole, that will be your object distance. So BP is U, and that is also negative. Okay, so one thing I will do here, I will write every value here. Okay, let's just write it here. FP is negative F. Okay, PB dash is minus V. PF is FP, same thing, minus F. Then here came BP or PB, that will be your negative U. Now PC, this is center of curvature to pole. What is that distance? PC is negative R, or negative R you can write negative 2F. So this PC I will write minus 2F. Okay, sorry, minus sign is already there, minus 2F. Okay, then below CP, I think CP not came now. CP already is there, so CP or PC same thing, that will be your minus 2F. And Then PB dash. PB dash is minus U. So minus sign is already there, minus V. Okay, PB dash minus V. Minus V came here. Now, just simplify it. Take the negative from here and cancel it. So this will become what? Here it will become F upon F. Sorry for the inconvenience, guys. So we will take F negative, you can take here, and negative also from you if you will take from here. So this will become your V minus F. Okay, and this will be cancelled. This side also you can take, if negative you will take. So this will become negative, you will take outside. So U minus 2F, and from here also negative sign if you will take. So 2F minus V. Okay, this is cancelled. So you will get F upon V minus F, U minus 2F minus V. Now you just cross multiply it and see what is coming. So we will cross multiply. This term will be multiplied here. So F in this is multiplied here. So F 2F minus V, and V minus F multiplied with U minus 2F. So this will become 2F square minus FV. Then this will become, this is also multiplied. So first multiply V. So VU minus 2FV. Then this multiplied here. So minus FU and minus plus 2F square. Okay, so this 2F square and 2F square will be cancelled. Okay, 2F square and 2F square will be cancelled. This minus 2FB, if it will come this side, so it will become positive 2FB. So positive 2FB minus FV is equals to UV, and this minus FU. Okay, so what it will become now? FV is equals to UV minus FU. So this is the relation you have got here. But this relation is not convenient for because in every time there are two things are coming. So we divide this whole equation by UVF. Okay, we will divide this complete equation by UVF. Dividing equation by UVF. So you will get FU UV minus FU. Sorry, FV is UV. So FUV, FUV, FUV. So what is cancelled? F and F cancelled, V and V cancelled, UV cancelled, F and U cancelled. So here you will get 1 upon U, here you will get 1 upon F, here you will get minus 1 upon V. So if you will take this V this side, so negative will become positive, and so this will become 1 upon U plus 1 upon V is equals to 1 upon F. This will be your relation. Okay, this is your relation. What is this relation? That is called as the mirror formula. Okay, this is mirror formula. So basically what you have done here, you have obtained the relation between image distance, object distance and focal length. Okay, among three things you have obtained the relation. Now one more thing, when you will do this, just remember what is its chronology. So first you have to see, you have to take this triangle and this triangle similar to each other. Its height and its height ratio you will take plus distance ratio you will take. So we have taken AB, A dash, B dash, F, and then we have taken triangle L, N and F. Both were similar to each other. दोनों सिमिलर थे तो दोनों के अपन ने लाइंस के रेशियो ले ली तो अपने से ये इक्वेशन मिल गया. ठीक है, बिकॉज A you have taken ln upon A dash B dash, and ln we have written is equals to AB. So ln we have written AB, which is equals to Fn upon FB dash. Fn upon FB dash. So Fn and P's are equal, so Fn can be written as Fp. Fn is equals to Fp we have written. Fn is equals to Fp we have written. So ln became this ln and AB are equal, so ln and AB are equal we have taken here, then this is there. So P, then Fn we have written Fp, and this F dash B we have written this Pb minus Pf. This Pb minus Pf we have taken, and this became your Fb dash. And that is our first equation, so we have left there. Then second we have taken triangle A, B, C and A dash, B dash, C. So in this also we have done the same. AB upon A dash, B dash and BC upon B dash, C, or CB upon CB dash. So again BC we have written in form of PB minus PC. PB minus PC, that is your BC. And C dash B also we have written in the same form, BP minus PC, and C dash we have written CP minus CB. CP minus PB, this we have taken. And that was your second equation. Both we have equated, and when both we have equated, we have got this relation. और जब भी यहाँ पे जब तुम वैल्यूज पुट करोगे तो ये जो वैल्यूज हैं Fp, this is only distance. When you will put its value, then you will put along with the sign convention. वहाँ पे तुमको sign convention, तो फिर ये values डाल के थोड़ा सा simplify किया और तुम्हारे पास ये relation है. So that is your mirror formula. Thank you.